Today we go over our first section of our linear functions foldable. Today on how to write a linear function given different setups. From our first setup, we have a graph and it's asking us to put it in our slope-intercept form. In this case, we need to find our y-intercept, our slope, and then we can create the equation. Using the definition of y-intercept, we're figuring out where it crosses our y-axis. In this case, it's at a value of 4, or the location 0, 4. Now to help with the slope, first off, let me actually write the answer down. So we have a y-intercept location of 0, 4. To find the slope, we want to find one other point and figure out the slope of its rise over run. Now an easy point is the x-intercept, where it crosses the x-axis. In this case, -6, 0. And then I figure out how to reach the point to the right. The reason why we go to the right, this will keep our x value positive. This will let us figure out if we go up or down. In this case, we are going up. A total of 4 units. And we go over to the right, a total of 6 units. Our slope in this situation will be our rise, the 4, over our run, the 6. Now we can simplify this fraction, dividing both the top and the bottom by a factor of 2, which would give us a new fraction, our simplified slope, of 2/3. So right now our y-intercept is the location 0, 4, and our slope is simplified to be 2/3. This simply means any 2 points that we pick on this line, we can always go some ratio up 2 and over 3 to get to those points. Our equation is simple. We'll have y equals our slope, which in this case was 2 over 3, multiplied to x. Our slope is always multiplied to x. And then we will add our y-intercept value. So since our value is a positive 4, we add 4. A table is a similar way of how we solve everything. We want to find out what our y-intercept is, which is whenever our x value is 0. So we are simply using the definition of y-intercept. And now in the terms of it's verbalized, knowing that our x value must be 0. So yet again, this would be our 0, 4. For our slope, we cannot pick just random 2 points on a graph and visualize a change. We'll have to calculate it using any 2 points that are on here. I already chose the 0, 4 location. So next I will use the 3, 6 location. The formula we use to find our slope is our difference in y values Difference means subtracting. Our y values are represented by the base 2, base 1. Sorry, let me move this over. Our subscript 2 and 1 show which point we are referring to, over our difference in our x values. Yet again, the subscript 2 letting us know which point we are referring to. So if we follow the order of what we received the points, this would be our second point that we chose. So we filled in our information. Our y2 value was 6 from the second point, minus our y1, which comes from 0, 4, being the 4. And we do the same thing with our x values. X from our second point, which is 3. And we're subtracting our x1, our x from our first point. Now in this case, we can clean it up. 6 minus 4 is 2. 3 minus 0 is still 3. So if you haven't noticed by now, our y-intercept and our slope is the same as our graph to the side. This means that our graph and our table are going to be the same line. In this case, our same y-intercept, our same slope, gives us the same equation. Two-thirds for our slope times our x variable plus our y-intercept value. So this is the table to our graph from example 1. Other ways that you can see this can be from its standard form. Standard form is when our x and y variable are on the same side and our constant value is on the opposite side. When you're doing this from standard form, you need to solve the equation, solve the literal equation, to be more specific. This happened in an earlier lesson. Forgot to change the settings to this. So in this case, our first step would be to subtract 2x from both sides. We want to get our y variable by itself. I'll show the step where we add terms in red. Adding the negative 2x cancels out our 2x. So our new line, which I'll leave in black, would be negative 3y is equal to, now I need to click off to show you this part, but we have negative 12 and negative 2x. These are not like terms, so I cannot combine the numbers. I simply write the terms next to one another. So we'll have the negative 2x just to keep the order of our slope-intercept, and then our constant. So I added the negative 2x term so that I can cancel out my 2x. And on the other side, I combine the terms, or I do not combine the terms, and I write the terms next to one another. So now we have one more step in order to get our y completely by itself. In this case, we need to divide by the coefficient. I'll show my work in red, the same way that I added a term. We don't need to see the underline again. So I'm dividing both sides by a value or a factor of negative 3. This keeps everything proportional, both expressions proportional. So each side is still going to be balanced. The reason why we divide by negative 3 divided by negative 3 is 1. Anytime that we're multiplying a variable by 1, we can just write that variable. On the other side, we divide each term by the negative 3. So we'll divide negative 2x by a negative 3. When we simplify this, they become a positive value. So now it is a positive 2/3. Let's get the font the same look. And this is in terms of x. And then we want to do the same thing with our next term, our negative 12. So negative 12 divided by negative 3. A negative times a negative is positive. 12 divided by 3 is 4. So when we're done with this, we have y equals 2/3 x plus 4. The standard form that we had, 2x minus 3y equals negative 12, was the standard form of our graph or our table. All three of these go together. So we can see our different equations in different formats. The last thing for this video is a verbal description. This is where we need to mark key features in the story, in the paragraph, that will help us create an equation. You can pause the video and read this by yourself. I'm going to jump directly into what I need to underline and why. After reading it all, we can break it down. We understand that we want to represent the total cost, y, for purchasing X charms. As you can tell, we've been setting up to be in slope-intercept form. All of these are y equals. So we know that we want to figure out that the total cost is equal to. Other key information in here. It says that Mary bought a bracelet for $4. She had to purchase it, no matter what, for a constant value of 4. Anytime that we have a constant value, that's going to be our slope, our y-intercept value. Reading more into this, we have our keyword every that is pointing towards our slope. Each, every, a day, or a are keywords that let us know that we are talking about some type of ratio, some type of rate, which is our slope. And it says that the store charges $2 for every 3 charms. So this is showing that it is 2 for every 3. This would be our rate, or in other words, our slope. The way we show this in an equation, ratios are shown usually by fractions. At least at this point, we have been showing them as only fractions. So this would be the $2 for every 3 charms that she buys. And this all depends on how many charms she buys. We use the X because we don't know how many she plans on buying at this moment. And then we know for sure that just buying the bracelet is going to cost her $4 or cost her $4. So this is how we set up our equation in slope-intercept form. We use the constant value as our B. It's our starting point, is another way to look at it. We were given a rate that was indicated by the word every. Every let us know that our first number will be top. And our second number, what it's comparing to, is the bottom number, 2 over 3.